Hello, software engineers and system designers. This is an engineering overview of ShiftShield, our mobile application for fatigue risk monitoring. We'll begin with a high-level view of what ShiftShield is designed to achieve. ShiftShield is fundamentally a mobile software platform focused on estimating and managing fatigue risk for workers with irregular schedules. The core function involves collecting critical behavioral data, including shift schedules, self-reported sleep logs, and caffeine intake metrics. This data feeds into a central processing engine, leverages persistent database storage, and results in actionable output delivered via a dashboard. This is our high-level architecture. Before diving deeper, let's frame the engineering problem that ShiftShield addresses. The technical challenge lies in modeling fatigue risk associated with non-traditional work patterns, where circadian rhythm disruption is a significant variable input factor that simple sleep trackers fail to capture. We require a dynamic, algorithm-driven system capable of accurately estimating and communicating elevated fatigue states based on these irregular inputs to mitigate accident risks. Now let's explore the system's foundational architecture, emphasizing modularity. Our design employs a layered architecture to ensure separation of concerns, isolating the client-side user interface from the heavy-duty data processing and modeling logic. The primary components include the mobile application UI, a persistent data storage layer, the core fatigue analysis engine, a dedicated recommendation generation module, and a real-time notification system. Understanding the data flow is crucial. Let's detail the inputs consumed and the outputs generated by the system. Inputs are time series metrics including defined shift start and end times, logged sleep duration, caffeine intake timestamps and amounts, and continuous time-awake tracking. Outputs include a numerical fatigue score, categorized risk levels such as low, moderate, or high, and prescriptive recommendations for sleep timing and caffeine consumption. The heart of ShiftShield is the proprietary fatigue risk algorithm. Our simplified model calculates the fatigue score as a weighted aggregate of sleep deficit, total time awake, and an estimation of circadian disruption, where each factor is assigned a specific weight coefficient. The resulting score is mapped into distinct operational risk categories, low, moderate, and high, triggering specific alerts and recommendations based on the severity level. The system design prioritizes modularity to facilitate easy maintenance and future expansion. Key independent modules include shift schedule processing, the fatigue analysis core, the dedicated recommendation engine, and the alert generation service, each operating with minimal cross-dependency. Future integrations are designed to include external APIs like Apple Health or similar wearable device data sources, alongside potential integration with existing enterprise workplace scheduling systems. To conclude, here is a summary of ShiftShield's engineering value proposition. ShiftShield is a scalable mobile software system with a modular architecture built specifically for robust fatigue risk modeling and poised for future integration with diverse health data sources, offering a foundational component for fatigue-aware scheduling systems.